Hello friends, we'll discuss now a new application of partial differentiation, maxima and minima. This is very useful and important to find maximum value and minimum value given function. It exists for given function. We have to check at which point our function have a maxima, at which point our function have a minima, or there some points are there satisfying not maxima, not minima points. And this very interested result under this heading of applications of partial differentiation. Before this, I will recall our concept of finding maxima and minima in one variable function. In one variable function, we are knowing that I will take here one variable function y is equal to f of x. This is a single variable function. To find out maxima and minima for this single variable function, we have to find out first its derivative, and we are comparing this derivative with 0, and when we are solving this equation, we are getting a stationary point. Y is equal to f of x function, we are finding its first derivative, that means dy by dx, and comparing to 0, and from this solving this equation, we are getting stationary point on points. From this stationary point, and I am supposing here to stationary point x is equal to a, when we are solving this equation, we are getting stationary point x is equal to a. For this stationary point, we have to decide this stationary point satisfying as a maxima or minima. For this, we have to find out double derivative. If we are finding double derivative d2 y by dx2 and putting value of this stationary point x equal to a, if this is less than 0, then we are saying that this function has maxima at x. And if this double derivative of this y with respect to x at x is equal to a greater than 0, then we are saying that for this function y equal to x have minimum at x equal to a. This is the technique to find out maxima minima for one variable function, single variable function. We have to develop same idea in two variable functions. And again, we are knowing that if two variable functions are there, then we are talking about partial derivatives, and we have to apply this logic, and we are generalizing this idea of single variable into two variable functions. We have to develop this idea to two variable functions. Now for this, we will note out some notations. This partial derivative of this function f with respect to x, we are developing this f of x which is equal to p, we are supposing this is p. Partial derivative with respect to y, we are supposing q. Partial double derivative of f with respect to x, we are supposing r. Partial derivative of f with respect to x and y, or y and x, this is equal to s. And partial derivative of this f with respect to y, double derivative of this f with respect to y is equal to t. Before going towards proof of this, how to find out maxima and minima for this two variable function, we will try to compare here using our single variable function. We are knowing that this single variable function is a double derivative of this y with respect to x greater than 0, that we have maxima, and this is greater than 0, have minima. Here also I will take double derivative of this function with respect to x. This is your r. Now surely we will talk something about this r. Now r is less than 0, then surely there exists a maxima at this stationary point. If r is less than 0, r is greater than 0, then there exists minima at x is equal to a. But again here, when we are finding double derivative, but here double derivative terms are there, r, s, and t. All these terms are in double derivative. And surely here we can talk about this r is less than 0 and greater than 0. R is less than 0 having maxima, r is greater than 0 having minima. In addition to this, we have to use this r, s, and t, because all these terms are in double derivative, partial derivative. Surely one thing is that r is greater than 0, we are getting minima, r is less than 0, we are getting maxima. Additional to this, some conditions are also there. We'll discuss about these conditions. Here, proof is also there to find out these conditions, how we are getting this condition, but I am not going so deeply for this proof. If you are interested, you should go through this proof. And here, we are getting maxima and minimum value, and we are finding our stationary points. From the stationary points, we are getting here maximum and minimum value. These values are called extreme value. So we have to find out maximum and minimum value. These are called extreme value. So please also there, you should go through this proof. We are getting maxima and minima in two variable function. This condition is important. Find out stationary point. Derivative is equal to 0 and derivative is equal to y. This is our necessary condition to find out stationary point. Again, this is necessary condition. Some conditions to find out our function having maxima or minima at stationary point. But now the important thing is here. How to find out maxima minima of given function. Now this working rule is there to find out maxima minima for our given function. I will discuss about this working rule, how to find out this and how to solve problems. First of all, we have to find out partial derivative with respect to x is equal to 0. Then find out partial derivative with respect to y and compare with 0. Using these two equations, we are getting stationary points. First, we have to find out stationary points. From the stationary points, we will discuss about maximum. But before this, we will find stationary point by comparing partial derivative of x with respect to 0, partial derivative of f with respect to y is equal to 0. By solving these two equations, comparing these two equations, from these two equations we get points, and 1 point also. And here, this is the stationary points. After this stationary point, we have to find out r, s, t. Now r means double derivative with respect to x, s means partial derivative of with respect to x and y, and t means partial derivative with respect to y twice. Now then we have to find out rt minus s square, and this r. We'll find rt minus s square, r, s, t are known, and we will find rt minus s square, r in stationary point, and r, and we are putting this value at this stationary point a. Now, if rt minus s square is greater than 0 and r is greater than 0, we have discussed, r is greater than 0, then at this stationary point, then our function having minima at a, and we find this minimum value. Again, second condition, if rt minus s square is greater than 0 and r is less than 0, then our function having maxima at stationary point, and this is your maximum value. If rt minus s square is less than 0, then at stationary point, the function having neither maxima nor minima at this stationary point, and this point is called saddle point. Saddle point means at that point we are not deciding whether this is maxima or minima. This point is called saddle point. If rt minus s square equal to 0, then we need some extra investigation. That means we write here no conclusion points. Rt minus s square. Now remember here, if rt minus s square is equal to 0, then no conclusion is there. Rt minus s square equal to 0, then this is neither maxima nor minima, or we say that this is saddle point. Now remember here, rt minus s square is greater than 0. If rt minus s square is greater than 0, then we have to check conditions on r. Rt minus s square is greater than 0. Then we are checking conditions on r. This r is either greater than 0 or less than 0. If r is greater than 0, then maxima is there. And r is less than 0, then minima is there. R is greater than 0, then minima is there. And r is less than 0, then maxima is there. Okay. In this way, we'll find stationary points, and we are deciding whether these stationary points satisfy maxima, mean or minima or neither maxima nor minima or no investigation, no conclusion. Using this data, using these rules, we try to find maxima and minima for given function. For this, we'll go towards our example. Discuss maxima and minima of x square plus y square plus 6x plus 12. Here, first of all, I will write this function as function of two variables f of xy is equal to x square plus y square plus 6x plus 12. After this, we have to find out first stationary points, and we are deciding these stationary points satisfy maxima, minima, or any other conditions. Now, how to find stationary points? To find out stationary points, we have to find out partial derivative of this f with respect to x and with respect to y, comparing with 0. This is the partial derivative of with respect to x. This is 2x, and derivative of this term is 0. This is 6. This is constant. Derivative of this constant is 0. Therefore, we are getting x square is 2x. 6 is equal to 0. Now, solving this, simplifying this, we are getting x is equal to minus 3. And partial derivative of this function with respect to y, we are getting directly to y. And comparing to 0, we are getting y equal to 0. So, we are getting from this equation, we are getting x is equal to minus 3, and from this equation, we are getting y is equal to 0. I will combine these two terms, equation 3 and 4. Now, from equation 3 and 4, we get x is equal to minus 3 and y is equal to 0. And this is our stationary point. For this surface, for this function, we are getting only one stationary point, and this stationary point is minus 2, 0. Now we have to decide this stationary point satisfying at the maxima, minima, or saddle point, or no conclusion. For this, we have to find out r, s, t. R means double derivative of this function with respect to x. And again, when we will find for the derivative of this function, we are getting this is equal to 2. R is equal to partial derivative of this function with respect to x, we are getting this is 2. If we find partial derivative of this function with respect to y, or partial derivative of this function with respect to x. If suppose I find partial derivative of this function with respect to y term is absent here, therefore we are getting this partial derivative 0. Therefore, s is equal to 0. Or you can find partial derivative of this term with respect to x. Then also we are getting this. Doesn't matter. You can find partial derivative of this term with respect to y or this term with respect to x. We are getting same answer. 0. Now we will find t. T means double derivative of this function with respect to y. Then double derivative is 2. Then t is equal to 2. That means we are getting r, s, t. Now after this we have to find rt minus s square. Now this is rt minus s square. This is r into t minus s square. R is 2, t is 2, 2 into 2 is 4, minus s square is 0. So we are getting this is rt minus s square is 4. Rt minus s square is 2 minus 2 into 2 minus 0 is equal to 4, and this 4 is greater than 0. We are knowing that this rt minus s square is greater than 0, then we have to move our cursor to r. Now when we are checking this r is greater than, r is equal to 2, and this is greater than 0. Now we are knowing, we are getting this condition as rt minus s square is greater than 0 and r is greater than 0. And this is condition for minimum. I am taking this rt minus s square greater than 0 and r is greater than 0. Of this, we get our function having minima at the stationary point minus 3, 0. Now this stationary point becomes the extreme point. And what is minimum value? We have to write f minima at minus 3, 0 is equal to, which we are putting this minus 3, 0 in our given function minus 3 here. We are putting x is equal to minus 3 and y equal to 0. Here from this we are getting minus 3 square is into this y 0 plus 6 into minus 3 plus 12. Minus 3 square if we are putting this, then we are getting this 9 minus 18. So we are getting this minus 9 plus 12 plus 20. This term is not written here, but by mistake. So note down this term plus 12, and then we are getting this equal to this minus 9 plus 12 is equal to this. How we will find maximum value? We have to put the stationary point in our given function to get this maximum value. So minimum, this is minimum. Therefore, we are getting this minimum values. Okay. Now, in similar way, we'll try to find maximum minimum for next problem. Here, our example is 3x square minus y square plus x square. Now here, we will write here f of xy is equal to 3x square minus y square plus x cube. First, we will find our stationary points. To find our stationary point, we have to find partial derivative of this function with respect to x and compare to 0. Find the partial derivative of this function with respect to y, compare to 0. This is our partial derivative with respect to x. This is 6x. Derivative of this function is 0. And this is 3x square. Compare to 0. Now, compared to 0, I will take whatever it will be common, I will take common outside. This is 3x into bracket 2 plus x is there. And solving this, we will get here 3 is constant. Here x is equal to 0 and this bracket is equal to 0. Therefore, we are getting x is equal to minus 2. And if we are finding partial derivative, we are getting minus 2y is equal to 0. From this, we are getting y is equal to 0. Now, using this 5 and 6, we will try to find the stationary point. Now, how to find? This is our 5. In 5, here first value is x is equal to 0. This first value x equal to 0 I will take, and then I will take this y equal to 0. Then we are getting first stationary point x equal to 0 and y equal to 0. That means 0, 0. Now, then I will take x is equal to minus 2, and here y is equal to 0. Then we will get second stationary point minus 2 comma 0. So here we will get two stationary points from this equation 5 and 6. 0, 0 and minus 2. Are you getting how to find stationary points here? X is equal to 0 I am taking from this equation number 5, and I am taking y is equal to 0 from equation 6. We will get first point 0. I am taking x is equal to minus 2 from equation 5 and y is equal to minus 6 from equation 6. We get this point minus 2. We are getting two stationary points. Now we have to decide which is the extreme point. Which point satisfying either maxima or minima. This point is called only extreme point. Now here we have to find out R, S, T. We find R. R means we have to find out double derivative of this function. 6 plus 6x. Yes, we have to find. Yes means we have to find out our first equation. We have to differentiate with respect to y, and the rating is or you can differentiate this with respect to x will get 0 and then t. T means we have to find double derivative of this function with respect to y. This is minus 2. Means we are getting r plus t. Now we have to find rt minus s square. This rt minus s square is equal to, I am taking r into t minus t square. S is 0, therefore 0 square. If we are finding this product, we get minus 12 into 1 plus x. Then r. What is r? R is here. This is your r. R is here. We have 6 plus 6. This is your r. Now, in last problem, this rt minus s square, this was constant term, and r is also this was constant term. But here this is in terms of x. Therefore, I will find this rt minus s square at this point, first point, and second. Here for first point, I am taking 0. Now rt minus s square. This is your rt minus s square. This one. I am putting x is equal to 0. Then we will get here minus 12 into 1 plus 0 is equal to minus 2. And this is less than 0. We are knowing that. If this is less than 0, then we are not considering about r. This is only we are checking if r about this term is greater than 0. Now this is less than 0, means this is a saddle point, neither maxima nor minimum. Means at this origin, at this point 0, 0, our function having saddle point. This origin is the saddle point for our given function. Then our second point, minus 2 comma 0. This is rt minus s square. This is your rt minus s square, minus 12 into 1 plus x. But we have to replace x by minus 2 and replace x by minus 2. Here we are getting this by getting minus 1. This is 12 and we are getting this by 12. 12 is greater than 0. If this is greater than 0, then we have to check for r. R is equal to, this is our r, 6 plus 6x. And we have 6 plus 6 minus 2, then this is minus 6, which is less than 0. Less than 0 means this is a, here, rt minus s square greater than 0, and r is less than 0 means function having maxima at this point, minus 2 comma 0. Therefore, this function 3x square minus y square plus x cube, our given function is given function having maxima at minus 2 comma 0 and maximum value f max at minus 2 comma 0 is 4. How to calculate this? We have to put in this equation we have put x is equal to minus 2 and y equal to 0. Putting this value, this coordinate in our given equation, then we will get this. This is the maximum value for our function. Now, again we will discuss. We should go through this exercise and try to solve, try to find extreme points. This is again interested example. Divide 120 into 3 parts such that sum of their product taken 2 at time shall be maximum. We should go through this one. This is again interested one. Sum of 3 positive number is a, something a constant number, you can take 8, and then determine the maximum value of their product. You can take any value a, or you should keep this a as it is and then find out this. Determine the maximum value of their product. You see here we are getting number of points are there, sum is are here also. If we are dividing this 120 into 3 parts, number of ways are there to divide this 120 into 3 parts. In here we are getting number of set of points, but this product is maximum, therefore we are getting again this is unique number, one number. So thank you for enjoying this lecture.